All right. So I used VR recently in this class. Rocks, Wind, and Women, Environment and Identity on Korea's Jeju Island. The class focuses on this one island in Korea. It's a shield volcano. It has a really distinct culture, even a distinct language. It's a pretty cool place. And since we're spending the whole semester talking about it, it seemed like it would be fun to take the students there virtually, if not in real reality. So we used the app Wander, which draws images from Google Street View and places you in that environment so you can wander around. These are my students, oddly enough, with their masks on and their VR headsets on. I don't even have to worry about privacy issues. You can't identify any of these people. But there they are with their beautiful Oculus headsets on, wandering around. They were following a route called the Ole Trail, which is the system of hiking trails around the island. As a hiking trail goes, it's really good. As a social phenomenon, it's sort of coerced a bunch of rural villages into the idea of having a hiking trail going through them with the concept of like business returns and profits, and it hasn't really worked out that way. So we look at it from all these angles, and then they got to look at it in VR. So I gave them a handout with some spots to look up because they had to be individually directed because of the way this app works. You can't have the entire class in a single spot at the same time. They had to sort of do their own little self-guided tour of the Ole trails. So the students were keeping journals week to week in ArcGIS story maps. And I pulled a few that mentioned their experience in VR. This person in particular, mostly just saying it was really fun. They'd like to try it again. Here's one where this student thought that it was really great to be able to see these things that they'd heard of but hadn't been able to visit. This is a student who's been to Korea and is familiar with it, but has not been to Jeju and hasn't been able to see these natural wonders. And then the interesting point, there are a number of beautiful waterfalls on Jeju. Yeah, seeing this waterfall, they were surprised that there were so many people taking pictures that you could barely see the wooden platform they were standing on. Because when you see photos of these waterfalls in beautiful places, they're all staged, like these beautiful tourist photos. But when you go and wander, you see that they are mobbed with tourists, that it's hard to get actually a clear shot of the beautiful scenery. And this really gives you a different perspective on the tourism issue and how sending this many people through the landscape can really affect both the landscape and the culture around it. So that was a really helpful exercise to be able to do with them. And this student also, again, mentioning waterfalls, then was sort of ruminating on how this could be a more sustainable way to visit the island because you don't have to, spend any fuel to get there. You're not imposing yourself on the landscape or the people on the island. And then also is a way to raise awareness about the island without necessitating that tourism of that scale. So really interesting thoughts came up. So to wrap up, I have some advantages and disadvantages. The advantages are obvious. Exactly the sorts of things you thought would be awesome about this exercise were awesome. It was just really fun. It was something very different to do. It was immersive in exactly the way it's advertised. Also, I think one of the interesting things about using Wander and using those Google Street View images is it's basically a primary source material. It's biased, of course, towards streets and paths, but it's not overly curated or edited. So what you see is just something that happened on this specific day in Jeju, and it's not staged like a beautiful tourist shot. It's often cloudy, it's often crowded, and you get to witness that. Also, the Ole Trail specifically is marked with a lot of different things. They're themed blue and orange, blue for the ocean, orange for the tangerines they grow on the island. And I had, when I was prepping it, had trouble finding one of these little ponies the kansei, which is the local word for a specific kind of pony. And so I let the students compete to see who could find a kansei first. And the person who did was very proud of themselves. So little tweaks like that is a very fun way to get the class engaged. In terms of disadvantages, I definitely have some inclusion issues that came up. Some people did have trouble tolerating the motion sickness issue, but even they enjoyed it and were willing to try again. But I did have one student who wasn't willing to try the VR at all. And I didn't really anticipate that coming up. But they really just were very reluctant to even handle the equipment. And of course, you can't force anyone to do something they're not comfortable with. But it raised an issue for me of if this were, an essential part of a course, if this were really a required element, what do you do about a student who simply doesn't want to engage with this kind of technology? Also, it's this class of 26 students, but they were basically each on their own. The technology isn't really built to have 26 people together in the same place, witnessing anything together, seeing each other, interacting in that way. It is individual oriented in that way. And it's really only suitable for an in-person course. I've been trying to think of how I could do it again next time, but I actually think I'm going to be teaching this course online or hybrid next time, and which would mean basically that I couldn't do this exercise and might just revert to doing Google Maps. It's on its own. And we all liked it a lot. We had a great time, but we never went back, despite Jan's invitation. We never went back and did another one because we couldn't think of another reason to do it. It was very hard to come up with real urgent cases where VR would be helpful. It was really great at getting a sense of the island itself and getting acclimated to what it really looked like, and was very helpful for that. But it was hard to figure out why we would need VR beyond that specific application. And then in addition, as the instructor, there's a lot of prep time. Doing the curriculum development for an actual session of VR can mean having a lot of hours ahead of time figuring out what students are going to do and what works, including even just getting your hands on the equipment. If you don't have your own Oculus, which I don't, it does mean putting in a lot of work, and we're all strapped for time these days. So I think that's an important consideration. But ultimately, I do feel like this was very worthwhile. And that's Wander. That's Jeju.
Casey, why don't you get us started?
Okay, good afternoon, everyone. Peter Knoop and I are going to give you a little sense of what we as geologists do. Many of you have probably taken a science course in your life, a chemistry course or a physics course. And as part of that, you do experiments, and you might mix something together and see how the acidity changes, or does the liquid become turbid, or does something precipitate? In many ways, what you're really doing is documenting that experiment. And those are the data from which you then derive some interpretation. In the same way, what Peter and I do when we lead a in-person field trip is we really believe that observation is the fundamental skill that students must have. And that is to be able to, at least from a broad sense, if you look at the picture on the left, you can see that there are different layers of rock. And those are sort of fundamental layers or units that students must then begin to document in terms of some sort of detail. Now, in person, a student can then begin to look at it in hand sample or with a small magnifying glass, but they begin to then produce a written or stored document, and this is represented here by this field notebook, where again the fundamental units are shown, but then on top of that, they then begin to add detail, which might be physical features or the kinds of fossils that are present. This basically represents what we can think about as a store of information that tells us something about the evolution of the environments that existed on the Earth's surface. observation and documentation are the fundamentals, the data store from which a student, as they begin to learn more, as they begin to have more educational training, can then synthesize and make an interpretation. The data are really the sort of the archive that's necessary. Now, one might ask, can you click to the next slide, Peter? One might ask, Peter, yeah, good. One might ask, well, why is this important? Well, one of the things, why did we go with VR? Well, an old geologist, I'm getting old myself, told me once, he says, geologists are only good as the number of rocks that they've seen. And that's because that's really that process of documenting and absorbing that information into one's intellectual framework. And you might say, well, why not maintain these as in-person events? Well, we certainly do. But in many cases, we found that there are times when a virtual event, a virtual exploration might be useful. And this came to bear certainly during the development of the pandemic recently. But in addition to that, we find that there are some students, either because of cost or because of physical limitations, are unable to go into these field activities. And perhaps more critically is really this desire to outreach to communities, high schools, communities that don't have the resources or the locations that are able to actually experience these things. And for that reason, Peter and I decided to undertake this to try to convert our in-person experiences into ones that can be enjoyed and learned from by people at other institutions and in other communities. At this point, I'm going to turn it over to Peter because he's going to begin to go through some of the technical things that we've pursued and some of the problems that we've also encountered.
Yeah, thanks, Casey. When we started building these virtual geology field trips, sort of our three building blocks were these immersive 360-degree videos, which give us the ability to direct students' attention to specific things, as well as give them the ability to explore around on their own. We have a number of high-resolution photographs that we also incorporate to give them an idea of rocks they're looking at. And we also have 3D photogrammetric models of some samples. Students aren't in the field. They can't pick up a rock and move it around, but they can do that in the virtual environment. And so the way this all sort of comes together, if I can get to the next slide here, is it's really we're letting the students interact with the video and drive the experience. So the 360 video you see in the center here, the students can pan around to look up and down the outcrop to get a notion of horizontal extent of some of these layers they're looking at. They can also zoom in quite a bit, and with the Insta360 camera we were using, they can see some pretty good detail, these low-angle cross beds here among horizontal layers. And it's sort of a step-by-step replication of what they're going to do in the field, but one of the most important things is enabling them to engage at multiple scales. So they can be zoomed out and see meter or so resolution things, a stick unit at the very top, interbedded unit here at the bottom that Casey's pointing to. You can zoom in on that unit, but there are limitations to what you can zoom in on. And so we've combined that by having hotspot links in the videos. So as they're exploring, they can stop and explore, and they link off to other assets we have, including self-assessment questions and other things. And it's really all about enabling a more in-depth observations while maintaining the context of the overall outcrop. And so in the field, a student can go up to a rock and look at it from all sorts of different angles. So we have photos that we provide that look at it from the edge or look at it from above. Critically, they all have some object in the photo. Here's the end of a rock hammer. Here's a US quarter. Because it's important to give them a sense of scale for the object or the image they're looking at. When they're in the field, they might use that rock hammer to break off a fresh chunk of rock to look at with a hand lens, which magnifies it about 10 or 20x. You can take a photo through a hand lens with an iPhone to get the product on the right, and we can include those in the virtual field trip. More importantly, we can start including things you don't have access to in the field. You might take that section of rock you broke off and make a thin section of it when you bring it back to campus to look at under a microscope. Well, we can take photos or videos of those microscope imagery and make them available as part of the virtual field trip experience. So it's letting us go beyond what we can do in the field. Similarly, we can provide reference photos or type specimens. So if students are trying to identify fauna in the rocks that they're looking at, they have some reference material. Again, that's something that's difficult to have in the field. There's also interactions in the field. You can physically interact with a rock. If you're looking at sedimentary rocks, often knowing whether it's made of carbonate or not is important. Students have little bottles of dilute hydrochloric acid. They can drop a few drops on it and see whether or not the rock fizzes, which indicates it's carbonate and releasing CO2. And we can capture that in the video so students can sort of perform that experiment virtually. Similarly, when we want students to be able to handle samples, we can't necessarily do that in the virtual environment with a tactile feel, but we have photogrammetric models of rocks that they can manipulate on their own, spin around, zoom, and pan and explore. They have quite high resolution. It's not captured very well in this video, but this still from the video shows it much better here on the right, that they can actually identify species and whatnot that they're looking at. We also have self-assessments envisioned as part of this. So, in the field, it's easy to ask the question of the group of what fauna are they observing in the rocks they're looking at. We have the same sort of thing possible here in the virtual environment, where they can check off what fauna they're seeing and get feedback on whether they're got them all picked or they need to go back and look again. Interestingly, and as Roy showed in hers, Google Street View is quite good these days. Casey and I visited this outcrop last October to capture the number of 360 videos. We noticed that Google Street View was there a month later, and you can see the resolution of their imagery is getting quite good. It's not quite there yet to see the scale of resolutions, but maybe at some point in the future, we can rely on Google Street View to provide the 360 experience, and we can just layer our materials on top of that. So what did we learn? The Insta360 camera has got great resolution. Of course, more would always be better. Good lighting is important. The right place and right time. Sometimes it's hard to coordinate when you're going to be at an outcrop somewhere in the U.S. as you're driving around. You don't have much control over that. Wind is something else that we ran into problems with. As illustrated in this video in the center, you can see the image is shaking quite a bit from the camera blowing in the wind. You also need a good sturdy tripod, which we didn't have. So the camera got blown over and the lens got scratched, which unfortunately we didn't realize right away. And of course, the most important thing out of 360 degrees ended up behind a scratch in some of our videos. But there are spare lens covers for these to pop off. Another key thing for these is audio to go with it. The lapel mics did a great job of filtering out all the wind or the roadway noise. Often these outcrops are right next to highways where they've blasted to put the highway through, so you have a great exposure. But that means you have to deal with a lot of background noise. We'll be replacing much of the audio with voiceovers, but it's really helpful to capture what you want to say while you're still there and thinking about it, or you may forget. The photogrammetric models, uniform lighting conditions are really critical. Full sunlight on a surface or overcast days are best. Some of the places we went to, this is Grand Ledge, just outside of Lansing, Michigan. Unfortunately, the shade from the leaves moving around in the sun made it impossible to get good photogrammetric models. As well as the software that we typically use, Reality Capture, has this great free education site license. We're having difficulty getting it approved through procurement at the moment. It's taken several months, but hopefully we're near the end here. And so our next steps is we're going to hopefully generate those photogrammetric models from our photos that we've collected over the last year or so. And we're going to be leveraging additional in-person field trips to capture additional sites, as well as go back to some of the sites in Indiana and Kentucky that we were showing here earlier. Our ultimate goal being to incorporate some of these virtual field trip experiences in the fall 2022 courses and begin to make them public after that.
We're good. Thank you.
I think I'll hand it over to you, Mark.
Thank you, Peter and Casey. All right, let's see if this works how it did at home. Maybe not. Give me 1 second.
How about now? That looks like it did it. All right, apologies everybody. I will try to do the quickest lightning talk that we've had so far. Okay, so mine takes a little bit of a different approach. This is sort of looking at my journey as a landscape architect and designer from using sort of 3D models for design and presentations into the world of VR. So for landscape architecture, there's a lot of different ways for understanding landscapes, and quite often the experiential aspects are down on the list of the way that people do it. I'm going to skip through for the sake of time. But I got really interested in looking at both the kind of visual aspects, but also looking at multisensory phenomena and how we could better use that to understand landscapes. And there's a lot of science to show that multimodal perception can really enhance perception of virtual environments, and that we actually can't even separate our sort of sound and vision from our perception, and that all perception is multisensory. So way back in the day, this is the late 90s when I was at the University of Toronto, we were looking at doing these visualizations for kind of urban design decision-making, with the real emphasis on the-ground experience. So we could do these comparisons of different proposals and how they might vary. This was using custom software that was designed at the University of Toronto, so Polytrim. And we were using these immersive kind of wraparound environments that at the time, I don't know if anybody ever used a Silicon graphics computer, but there were these gigantic things that cost about $500,000. Jeremy mentioned our current U of M campus model. This is a model that I worked on at the University of Toronto. So for being 25 years ago, I think the photorealism was kind of ahead of its time. And with those big Silicon graphics computers, we could really do, you know, real-time exploration of these environments. Cut to maybe 10 years later, and you're looking at, you know, hardware advances made these immersive visualization labs drop from half a million dollars down to about $4,000 US. This is a project that I built. And I think, interestingly, you know, our keynote speaker mentioned about interacting in different ways with these environments and data. You know, a student used this environment to develop this timeline of a project, and he said he wouldn't be able to have done it without actually just moving through it. I'll skip this because we are here because of VR, but obviously much more accessible now. Unity gives us different effects, character models, animals, artificial intelligence. And what I got really interested in was looking experimentally at the differences between the different ways that we're interacting with these environments. And there is research out there, so a decent amount looking at VR in particular that I'll talk about today. But there's a lot of conflicting evidence of parity of experience between VR and other experiences. So some experiments compared real world experience versus 3D models with sound and found no difference in evaluations. Some used real world versus 360 video. No differences when people assess the soundscape quality, but significantly lower spatial quality when using a VR headset. And then looking at, say, panoramic projection versus a VR headset, increased realism and presence in the VR headset. So a project I did with some students years ago now, we were looking at panoramic visualizations versus merely large screens. I won't go into too much of this, but a lot of the qualitative feedback was dizzy, confusing, boring. So this was the immersive visualization, and it just sort of overwhelmed people. Some work coming out of my PhD looking at how sound can contribute to environmental visualization. Again, I won't go into, for the sake of time, too much detail, but all of these little bars show you the difference that sound has on people's realism ratings and preference ratings, top and bottom respectively. And then more recently, looking at audio fidelity and virtual reality. So we were looking at a no sound condition, an ambient generic sound, and realistic sounds. And the sound conditions significantly increased people's preference across all environments. And then in terms of realism, there was a slight increase between viewing on a screen and in VR, and similarly with sound, going from no sound, ambient sound, and realistic sound. And currently we're working on more of a psychophysiological approach. So looking at skin conductance, comparing that to this effective slider where you can get arousal and pleasure ratings from people. We'll speed through, but on the right, you see the kind of skin conductance levels in VR compared to looking at a screen. So obviously something going on there. We still have to kind of unpack that. There's a lot of sort of cross-contamination that could happen. That might just be because they're moving their head a lot more. So you do have to be pretty rigorous in the experimental setup. Now, in conjunction with academic innovation at the University of Michigan and Jeremy Nelson and the XR initiative, looking at taking these landscape performance case studies that we work on. So these are to communicate kind of landscape architecture benefits to people and other landscape architects. We developed these websites. Now we're taking this experience into Uptail and really looking, I won't play the video, but here you can, in VR, hear the actual rain falling and witness where the water is actually moving and how the drainage works. Similarly, the same landscape at night, and they've got these interactive light elements. And then now looking at kind of how this transitions into public engagement and a lot of the other sort of work I do that's less experimental. We've developed this software where people can design their landscapes. They get feedback in terms of metrics. We have it currently working on an iPad and web browser, and we're looking at transitioning this to VR and potentially AR so that people can use it to design their landscapes. And that's it. Apologies, I think we are 4 minutes over.
Yeah. Thanks for coming, everyone.
Thanks, everyone. That was my real version of a lightning talk. It's like the sprint.
It was really impressive.
Thanks to my fellow speakers. It was super interesting.
I agreed. Thanks, everyone.